So far, we've been saving our functions as separate files. That's fine if you're only working on your own computer, but you might want to share your function or your file with someone else, like your instructor, to show that you know how to do things. And you might have a problem like this that asks you to create a function and show that you can use that function all in the same assignment. So the question is, how can I submit one file that does all of this? And the answer is subfunctions. Within a function file, you can have multiple functions being named and defined and used, so those functions can use each other. I'll show you how it works, but let me give you a quick description. We're going to have one big overall function whose name will match the file name. But after that function is over, after it has reached its end, so we have function and then we have stuff and we have the word end, and after that we get to put subfunctions, additional functions for use in that file, so that any code in that file can call those functions. Let's try it. Let's put it to use. So I've cleared everything off here. I've got a brand new file, and MATLAB doesn't know yet if this is going to be a script file or a function file. But as soon as we type the word function, it knows. So your main file, the overall file that you're going to use to submit homework or challenge problems, is going to be no output and your file name right here, and then no input. So for me, I'm going to use my last name, first initial, and then maybe this is challenge problem 4, or maybe it's homework 5, or maybe it's example 1, or whatever. So put in the, I'll just call this example. Put in the name that you want your file name to have as your main function. So, and then here I'll put, this is where my header cell information goes, so I'll put my name and the date and which problem I'm doing. All goes in that little header cell. We don't need to have 2 percentage symbols anymore. We could. Okay, maybe it's a good idea, but we don't have to. Let's go ahead and do it. So then I have the description of the problem. Notice that there are no inputs and outputs here, and so then this is where all my script commands go. Everything that I'm going to do to show my instructor I know how to do something goes here. And then I'm going to have the word end, and notice we've got this helpful kind of formatting on the side that says, hey, these things are related. And you can minimize the header cell if you want. But I've got the function and I've got the end, and after that is where I'm going to define my subfunctions. So let's create, let's actually do one here. Let's say create a function to calculate the number of primes, then use it a few times in a test code. So here's when I figure out, this is where the testing will go. This is where the testing will go. But I'm going to define the actual function later on, after the end. So this is what's called defining your subfunctions sequentially. That means one after the other is over. I'm never going to put a function inside of another function. I can call it from inside another function, but I'm not going to put the definition where I'm saying, hey, here's this function, here it exists, inside of another function. That would be called nested subfunctions, and we're going to avoid them 100%. All of your subfunctions should be sequentially defined, guaranteed, always 100%. Okay, so I've got the word function, no output, the name that I'm going to use for my file, no input, got my info, what I'm going to do, and the word end. And down below, I'm going to type the word function again and say I'll have output I'll have the equal sign. So this is just as if we were doing the whole file. I'll create a new function called number of primes, number of primes, whatever. And then I'll have an input, and it will be a single number, which I'll call n. Okay, so that's how we define a new function. It's giving me a warning that we haven't used n yet. Yeah, I know, we just got here. And don't forget that every function has to be paired with the word end. So here's the layout. My overall main function will start at the top, and I'll have the name of I want to use for my file. And then I'm going to have some stuff. I'll come back and fill that in, and the word end. And then after the word end, we have new declaration. Function, the name of the output, the name of the subfunction, and the word end again. So let's see, how do you find the number of primes of something? I feel like there's a built-in MATLAB function for that. So we'll just borrow that and say, okay, you've got a number n. I'll say, let's call a equal to primes of n. So this is the built-in MATLAB function. This, by the way, every function deserves a little bit of commentary. Every function and subfunction should say what they do, and in the case of subfunctions, where they're used. So this function finds the number of primes less than or equal to n. Used, well, if we had more than one, I might worry about where they got used. But for now, let's keep it simple. So this is a built-in MATLAB function we're kind of borrowing. And then, so I called it A. The problem is, what does primes do? Let's get help on primes real quick. Remember, we can just type the word help. Primes is a built-in MATLAB function, and what it does is it gives you a row vector of all the prime numbers. So it's not a count, it just gives them all to you. So what we want to do is find how many there are. So just as an example, let's do primes of like 9. Primes 9. How many prime numbers are there less than or equal to 9? Well, there's 2, there's 3, there's 5, and there's 7. That's great, but what I want in my function is how many that is. So this generates an array of primes. And what I want is the size, but not the size which gives me both the number of rows and the number of columns. I just want the number of columns. So I do that by saying, let's let the output be equal to the size of A, but only the second value. I don't want the number of rows because I already know that it's 1. So size of A, but I only want the second part of it, the second value. We're skipping over the number of rows and saying just report the number of columns. All right, and let's make sure that this works by saying size of answer 2. Yeah, 4. That's how many columns there are. So I've got size, which is another built-in function, and this is going to give me a count. How many items were there in A? That's what I want, so I'm returning that as the output for this function. All right, so that's all this function needs to do. This tells number of columns in A. So I don't care about the number of rows. I know there's only going to be 1. I just want the number of columns. That's what the 2 is doing. All right, now that we have our subfunction ready to go, I'm just going to copy the name of it to make sure I don't mistype it. And back up here in my main function, this is where the actual testing will go. So I'm going to call it using this number of primes. So I could say number of primes 9, and I want that output submitted to this command window, so I'm going to not suppress this output. Maybe I have a whole array of values. What I absolutely must not do here is reuse the names of the local variables from my subfunction. So remember, I called it n, I used capital A, and I used the output called output. we could change that and say, you know, maybe that's y, and then I'll call this y here. It doesn't matter what we call it, it just needs a label that's the same in this line as it is in this line. So MATLAB knows, oh, that's what you want to send back to whoever called this function. But the point I'm trying to make here is you should not reuse the same variable names inside the function that you do outside the function. So over here I called it n. I need to call it something else. I should not use n. I will use x instead. So maybe x equals 15, and I'll run num of primes 15. Oh, I should have made clear and CLC part of my function actually. Let's go ahead and add that in, clear and CLC. That'll give us a nice fresh workspace to start from. In this case, we're going to get, I don't need to see that x equals 15, but number of primes for 9 and the number of primes for 15, which I expect will be a larger number. Let us, let's go ahead and run it real quick. There's 3 ways I know of to run a function file like this. You can drag it in from the current folder space. You can type the name of the function directly into the command window, or you can click the run section, which I believe also will save it for me at the same time. So yes, now it's saved, and I see I've got A still reporting, so I should probably suppress that output. But I've got the 1 for 9, which was 4, and then the number of primes for 15, which was 6. All right, we'll look more at formatting and making these answers into nice, pretty sentences in a future video chapter. But for now, that's enough to get us started on functions and subfunctions.